I would like us now to move on to multiplying binomials. It sounds like you've done this before. We're going to use an L-shaped frame to multiply the binomials. But I would like to suggest that before students do that, they really need to look at the addition of polynomials and subtraction. They need to go through all of those steps before they do multiplication. And for the sake of time, we're skipping those steps today. However, in this PowerPoint, you will find a link to a wonderful PowerPoint from Math Bits that takes you very gradually, step by step, from representing expressions to completing the square and solving quadratic equations. Have you used that PowerPoint? Thank you. I use it all the time as well. So if I were to teach that to students who had not seen it before, I would just go with that sequence as it was outlined in a PowerPoint. So when we multiply binomials, I want students to talk to me first about the area. What does multiplying really mean? What does it mean in geometry? And I want our students to look at this as maybe finding the area of a rectangle. This could be length, this could be width, and the product represents the area. So then students are thinking in terms of, oh, I need to build a rectangle. So we need to ask our students first to outline this problem on the outside of the frame. This is when the dimensions come in handy, right? So how do we show x plus 2? We need one x, right? And how many ones?
2.
2 ones. Now on the other side, we're going to show x and how many ones? 3. Going back to what multiplication means, going back to the geometric connection. If these are the dimensions of our rectangle, could we not find the area? And all we have to tell our students is, fill in this space, place your tiles in this space. And I would always maybe recommend, if students are a little bit stuck, I would maybe say, fill it in the most efficient way possible, and do think about the dimensions that you have on the outside. And just let them go and see what they'll do. Don't over-explain. Let them try, they will surprise you. So how did we find the answer to this problem? How did we find the area? How do we show it? What does it look like? So you have, what are all the tiles you have in this space right here? Just let's name the tiles.
1x squared.
1x squared.
5x.
5x.
And 6.
And 6. And this is when we can talk to our students that this is great that we usually place ones at the bottom right. So this is a good place to talk about the structure here in our algebra tiles area. And if you notice that all the different tiles sort of come together right here and they touch each other right here at this point, right? And we need to talk about too how this 5x now represents what?
Those two.
2x plus 3x. So we combined like terms. Very good. I've heard so many aha moments and comments from students. Oh, I'm actually getting this. I'm actually good at this.
Our students have worked a lot with the distributive property over the years. And we don't even have to talk about that. It will come out. If we do enough examples like this, and we lead them to what is the connection with that 5x and the
Where's it
problem I
coming from?
had? Okay, maybe we don't get it this time. Let's do another one. Let's do another one. And then they're going to get the pattern, and they're going to come up with, oh, this is just the distributive property. And then somebody's mama might say, we call it the FOIL method. And then we get to compare that strategy to what we did with the concrete representation, and they can see how FOIL came about.
See, the good question would be to ask, why does FOIL work?
Right.
Can you justify the method? That would take them right back to the concrete, because this is the why. This is the conceptual piece. Others are algorithms, the shortcuts. But again, and there's nothing wrong with shortcuts as long as there's a foundation, right, for that.
They'll come back to the shortcuts once they see that it works.
Next, sometimes we'll have negative numbers, right? Let's try that one.
I am curious when you do this with students. I've never done multiplying binomials with algebra tiles. Do you use integer rules to know what color to have here, or do you just go with the concept of the negative means opposite?
What do you think? How many of you have multiplied binomials in the classroom? How would you answer that question?
I would use the integer rules because you're actually multiplying these together to produce that one.
I do mention that too. So notice that you have a negative right here and a positive right there. What would be their product? I think it's okay to say that, right?
And I think most of mine, when they did it, they wanted to turn them all to the positive, which was fine with me because then I could go back when they think they have it right and say, I want you to think about your integer rules, and when you're multiplying that one positive by that negative, what color would that be? And they go, oh, I need to flip those over. And so
They get it real
then they
quickly.
started going back to their integer rules, so.
I was going to say it was a good formative assessment for me when we would do this task because you could see which kids could remember the integer rules and who couldn't. They weren't sure because they would be like checkerboard. I don't know if they're
Or they
supposed to be
weren't even
positive.
thinking about them. They were just thinking about what tiles were gonna go where, and then they could go back and go, oh, I have to think about that now.
And actually, it might be good to, before you even multiply binomials with tiles, to really go back to that PowerPoint I mentioned and do addition and subtraction with algebra tiles. When you have those zero pairs or additive inverses, when you move them out, and then move to multiply and dividing with algebra tiles, because it takes them step by step. And I think that will conceptualize the integer rules that we mentioned, because that would show the concrete examples of those positive and negative integers, and then take them to the multiplication. So I really think that flow might be important to prevent that from happening when we come to this point. So let's see what happens here. It's a little bit interesting, right? X and 4 ones, right? And another X and 3 negatives. Jennifer mentioned something that always comes up in the classroom. Would you share that, please?
When you're building your tile multiplication, some students might wonder, does it matter? Do I always have to put the first number on top and the second term on the side? And as opposed to just saying, I don't know, maybe Suzette, you put it this way, and Laura Ann, you put it this way, and let's see if you get the same thing. So that can be an aha moment for them, using the commutative property
Back
for
to that
multiplication.
importance of the property and the meaning of that. Or we can just always say, I don't know, what do you think?
Yeah.
Show me, try both ways and tell me what, like you said, what the answer is, what the product is. So would this represent our final answer, this part right here? Or is there something we can do?
Additive inverse.
Additive inverse.
Yes.
All right. So we can see some x's that will create an additive inverse. So what do we do with them? Match them up and there you go. So this will be matched up, right? So what will be our final answer now?
X squared plus X minus
1x.
12.
Minus 12. Beautiful.
And one thing,
Yes.
Irina, I think it's very important, I put mine on the wrong page, but I think it's very important to put it on the model, or we in the algae blocks, they have like the plastic things that you use, because kids might get confused, they get confused with what's on top and on the side, so you really need to use that,
The L-shaped.
L shape, yeah.
It's very helpful. I noticed that. And some kids want to draw an L shape. Some like, and I might say, hey, you can just draw one
Yeah.
on notebook paper. But some really liked ours that are very, aligned and models that you're using right now. And I would like for Kiri now to share her observation earlier that actually goes right along with another one of the handouts that you have. Thank you.
I just noticed, I didn't, when I was teaching this years ago, I did not use algebra tiles at first. But I went to we call it the box method, which is basically just the area model. And how it fits perfectly in the box. Because you have your x squared usually at the top left, and then you have your, like for this next one, you'd have your 4x, right? And then, it just fits perfectly. So I would take that anchor chart right there with a different color
Yay.
marker and just go boom, boom, and let them see. Now you don't have to use the algebra tiles. You can transition right to the area model.
Absolutely, and this is a great student handout that you are receiving after today's workshop. It does take you from algebra tiles to the area model that you've mentioned, and then to the more abstract representation.